Everybody, welcome to my YouTube channel Easy Mathematics. In our previous lecture, we come to know that how a infinite GP series for we find out its nature, that is it is convergent or divergent or oscillatory. And we also know in our previous video lecture that what is the series of positive terms. Now, when we are finding out the convergence of an infinite series, then we usually find out the sequence of partial sums, and after that we take the limiting value of that nth partial sum where n tends to infinity, and depending upon that we calculate or we should find out that the given series is convergent or not. But always to find out the partial sum and take its limit while n tends to infinity is not that much easy. In all the situations it may not be possible. So to avoid this difficult job, a number of methods and rules have been developed for examining the convergence of an infinite series. So out of all those different methods and the rules, here I am discussing one of them, that is the comparison test. And that test is the most important one among all the available tests by which we can find out that a series is convergent or not. So first of all, what is convergency test? At first we should come to know that. After that we solve some problems by using that test to find out its convergency or divergency nature. So first of all, comparison test. It has the different formation. If two series summation un and summation vn of positive terms is such that first of all summation vn converges and un is less equals to vn for all values of n, then we can say summation un is also converges. So just look, any series summation un is given for our solution. That means we have to find out the nature of the series un. On that basis, we should just create or we just assume a series Vn in such a manner so that un, its nature is previously known. That means we should know that if this one is convergent and if un, that means all the terms of the given, that means of the required series for is less than equals to Vn for all values of n, then we can say un is also converges. That means if Vn convergent, then un is also convergent provided this criteria should be verified. Similarly, for the divergence, we can say the similar way. If two series summation un and summation vn of positive terms be such that summation of n vn is divergent and un is greater or equals to vn for all values of n, then we can say summation un is also divergent. First of all, you just remember here, whatever the series we consider as un, these all are the series of positive terms. Now vn is another series. With respect to that, we want to compare what is the nature of un. So vn is a series whose nature is already known. So after that, depending upon that inequality, either this one or this one, we can say un is divergent or convergent. This comparison test for, we have a limit form. So that limit form is the most important one and the widely used form for the comparison test. In this form, what we will do, at first, two positive term series we have, that is summation un and summation vn, in such a manner that limit n tends to infinity, un by vn is equals to L, where this L is definitely not equals to 0 and a finite quantity. If we will find out so, then summation of un and summation of vn converges or diverges together. That means if vn is convergent and this limiting value we will find out a non-zero finite quantity, then we say summation un is also convergent. Again, if vn is divergent, then summation un is also divergent. Beyond these three forms, we have one more form for the comparison test. In this form, what we will have again, Vn and Un and Vn with a series of two positive terms, and if we will say or if we will find out that Un divided by Un plus 1 greater than Vn divided by Vn plus 1 for all values of n, and summation Vn is a convergent series, then the series summation Un is also convergent. Just this is called the ratio form because we have the Un and Vn. From there we can easily find out Un plus 1 and Vn plus 1. After that we take these ratios, and if this ratio is for this relation, this inequality satisfies, then we can say that the Un is convergent provided Vn should be a convergent one. Similarly, if we can just do the opposite inequality, that means Un divided by Un plus 1 less than Vn by Vn plus 1 for all values of n, and summation Vn is divergent, then the series summation Un is also divergent. On that respect, we should note few things for this comparison test. So first of all, we will discuss here four different forms for the comparison test. Among all these, the limit form is the most useful. Second one is summation Vn is called the auxiliary series. Summation Vn is called the auxiliary series. Next, summation Vn must be chosen so that limit n tends to infinity, Un by Vn is a non-zero finite value. And the last thing, that is, depending upon the nth term Un of the series summation Un, Vn is of highest possible degree in 1 by n, which is usually a P series. So what this last observation says, that how this Un should be chosen so that we can compare the given series Un with respect to Vn. How we will choose this Vn, that we will discuss when we just doing some examples. But before that, just remember that Vn series in most of the cases P series. I hope you can remember this term P series because in our previous videos we have discussed two special type of series. One is the geometric series, another one is the P series. So in most of the case, if we take the Vn as in the form of either a geometric series or in the P series, then we know the nature of the series Vn, if it is geometric series or P series. So depending upon that, we can calculate Un. So how this convergence, how this comparison test we apply for the various problems where the series is an infinite series and with the positive term series, for that we just discuss the example. So just look at the example now. So the first example is test the convergence of the series 1 plus 1 by 2 square plus 2 square by 3 cube plus 3 cube by 4 to the power 4. So this one is your series. So now our requirement is to verify or prove the convergence of this series. So first of all, let us consider the nth partial sum is this one where we just omit this first term. If we omit this first term, then we will find out this one as an infinite series. And we know by insertion or deletion, few number of terms will not change the nature of the series. That is a fundamental theorem of series. So now here from we will find out that Un is equals to n to the power n divided by n plus 1 to the power n plus 1. Because just look at this, the terms, all the terms are 1 its whole square, 2 1, then 2 square, 3 cube, 4 to the power 4, and here in the denominator it is 2 square, 3 cube, 4 to the power 4, 5 to the power 5. So accordingly we will find out Un is this one. Now let us consider Vn is equals to 1 by n. So now the question is why we have considered Vn is equals to 1 by n. That understanding is very essential. So how to find out what should be our Vn? So at first we just observe the denominator and numerator of this Un. After observing these two, so denominator and numerator. Now after getting this two, find out the difference of the degree of the denominator and the numerator. So here just look n to the power n. So in the numerator the highest power of n is n. And in the denominator the highest power of n is n plus 1. So the difference between these two powers is 1 exactly. So as the power is 1 and here this one is the greater than this one, that's so why we take Vn is equals to 1 by n just to adjust. That means our target actually to make these 2 degrees equal. So for that, whatever the difference we will find out, we just adjust that difference by this Vn. So as the difference between these two is 1, these two means the degree of the denominator and numerator in un is 1 for the variable n. So that we take Vn is equals to 1 by n. I hope it is clear. So now after choosing this one, we just apply the comparison test. So while we apply the comparison test, then we will find out that the limit n tends to infinity un by Vn should be equals to this one. Here just look, un means n to the power n divided by n plus 1 to the power n plus 1. Now if we take divided by Vn, so Vn is 1 upon n, so that n should be adjusted over here. That's why it becomes n to the power n plus 1. Now if we simplify, how to simplify? We just simply divide this n plus 1 divided by, that means the numerator and denominator, both we should divide by n to the power n plus 1. So that we will find out it is 1 divided by 1 upon n to the power n plus 1. Now if we just simplify this one as just by splitting these two terms, so that we will find out these two, where we know this 1 plus 1 upon n to the power n is equals to e. That is the exponential term where limit n tends to infinity. That also we have do in some special sequence. And for this one, if we take the n tends to infinity, it is 1 plus 1 upon infinity means it is 0. So finally we will get this one. So here from we will have 1 upon n. So 1 upon e. So 1 upon e means e value we know it is lying between 2 to 3. So 1 divided by e means it is a non-zero finite value. So what we will find out from here, this limiting value is a non-zero finite one. And Vn, the summation Vn is the series, which is this one as per our consideration. And this one is nothing but an infinite series, infinite P series. So here P series, this one 1 by n, this one is a P series where the P value is 1. I hope you can understand, because our P series is 1 by n to the power of P. Here P value, if we consider 1, then this one is an infinite P series. So for the value P is equals to 1, we know the P series is divergent. So Vn is a divergent series, and by comparison test we will find out the limiting value is a finite non-zero number, so that we can say summation un is a divergent series. I hope you understand. So we should go for the next one more example. Here is the second example. So if this one is your given series, so here un is equals to 1 by root n plus 1 by root over of n minus 1. So if we simplify, we will get this one. And now just look here, the denominator having power or highest power of n is root, that means n to the power half. And in the denominator, the power is 1 exactly, because under root it is n square, means outside the root it is n exactly. So the difference between these two power is the n to the power of half. So that we consider Vn is equals to 1 by root n. Now we just apply the comparison test here. We just substitute un, this value, and Vn is 1 upon root n. That is root n is here in the numerator. So that we just simplify. And if we apply the limiting value, then we will find out this value is 2, which is a non-zero finite number. Again, as per our choice, Vn is 1 upon root n. That means the power is 1 by 2. And this is again a P series, where the P value is half, which is less than 1. So P value is half. When it is less than 1, then again it is a divergent series. So that from here we can say that un is a divergent series. So one more example is what? That is, if the given series is summation 1 by root n tan of 1 by n. So here a bit different type of series is this one. So here un is this one, here no doubt. But what should be our Vn? If this type of trigonometric terms are involved, then Vn should be whatever be the n are there, its multiplication. That means here it is in the denominator, n is root n, and here it is n. So its total multiplication. So that is Vn should be, we consider 1 upon root n into n. That is actually 1 upon n to the power 3 by 2. Now the same way, we just apply the comparison test, take the limiting value, and here the limiting value is 1, which is a non-zero finite number. And as per our consideration, Vn is this one, which is again a P series, and the P value is 3 by 2. So that 3 by 2 means it is greater than 1. Hence, the Vn is convergent. As Vn convergent, limiting value is a finite non-zero value. So that we can say Un is also convergent. One more example let us discuss. So here, the given series is summation of 1 by root over of n factorial. So just look, first of all, we know for the factorial notation that if we consider 3 factorial, then its value is 3 cross 2 cross 1. That is always greater than 2 cross 2. That is, we can write 2 to the power 2. If 3 factorial, then it should be always greater than 2 to the power 2. Likewise, if it is 4 factorial, then in the similar process, 4 cross 3 cross 2 is greater than 2 cross 2 cross 2, we can say. So that one is definitely 2 to the power 3. So we can say 4 factorial is greater than 2 to the power 3. Likewise, n factorial we can say it should be greater than equals to 2 to the power n minus 1. Why this equals to sign we have considered? Because if n value is exactly 2, then we will find out this equality value. So anyways, n factorial is always greater than equals to, we can say, 2 to the power n minus 1. So that is the factorial criterion or factorial characteristics we can find out. So that the given series is this one. So if we compare accordingly this one, so we can write n factorial is greater equals to 2 to the power n minus 1. Definitely for all n greater equals to 2. Now if we take root on both sides, then we can find out root over of n factorial is greater equals to 2 to the power n minus 1 by 2. Now if we take the reciprocal, so then it is 1 upon root over of n factorial is less equals to, reciprocal means this greater than definitely be reversed in the less than. So that one we will find out, and we say this one as our Vn. So Vn is a series which is 1 upon 2 to the power n minus 1 by 2. So we can say it is 1 divided by 2 to the power n minus 1, its root. So that one is a geometric series, I hope. So this one is being a geometric series with the common ratio is 1 by root 2. 1 by root 2 is again less than 1. So a geometric series having the common ratio less than 1 is always convergent, that we know. As this one is convergent, so that we can say the summation Un is also convergent. So by the comparison test, we can definitely say so. So now a very important thing I am going to discuss. That is, we know the P series and how to prove that P series is when convergent, when divergent. In comparison test, going to prove that the P series is convergent when P greater than 1 and it is divergent when P is less than equals to 1. So its proof for, at first we consider the situation where P is greater than 1. So the given P series is this one, summation of Un, that is, we just explicitly if we write, then we will find out it is 1 plus 1 by 2 to the power P plus 2 to the power 3 to the power P. In this way, that is. Now what we will do, first term we just say as the first term U1. Now second and third term combinedly we say it is the U2, second term. Now for the next 4 terms we say it is U3. After that next 8 terms we say it is U4. Likewise we construct this series. So here all the terms we have included. Now what happened, why we will do so, that you will understand just in a little while, that U2 means it is 1 by 2 to the power P plus 1 by 3 to the power P, which we will find out that if we replace this 3 by 2, then we can say this should be less than of 1 by 2 to the power P plus 1 by 2 to the power P. If we simplify, then we will find out it is 2 upon 2 to the power P is equals to 1 by 2 to the power P minus 1. Now if we consider U3, so then this one means there are 4 terms. Now each term here 4, 5, 6 and 7. So this all, if I just replace by 4, that means 4 to the power P, 5 to the power P should be 4 to the power P, 6 to the power P also be replaced by 4 to the power P, 7 to the power P also as 4 to the power P. So we will get this one. So definitely we can say this one should be less than of this one. And if we simplify, we will find out it is 1 upon 2 to the power P minus 1, its whole square. Likewise, in general, we will find out Un is less than 1 by 2 to the power P minus 1 whole to the power n minus 1 for all n greater equals to 2. So now since p is greater than 1, so that this 1 by 2 to the power p minus 1 should be less than 1. Because p greater than 1 means 2 to the power some negative power, positive power is there. So that is this ratio definitely be less than 1. Now as summation Vn is this one, we say this series, this one is the Vn. So as this one is this, which is a GP series with common ratio 1 divided by 2 to the power p minus 1. So which is definitely less than 1 as p greater than 1. So that we can say Un is also convergent series. Now when p is equals to 1, that time we will find out that when p is equals to 1, the entire series becomes an infinite HP series harmonic progression, and which we know that it is a divergent one, which we prove in our previous videos. Next, when it is p less than 1, that time again we can compare each and every term in this inequality form. That means the 1 by 2 to the power p is always greater than 1 by 2. 1 by 3 to the power p always greater than 1 by 3. Likewise, 1 by n to the power p is always greater than 1 by n. So just look, if we say HP is the Vn, our comparative series which we consider, that is a infinite HP series. And with respect to that, if we compare, then we say that Vn is divergent, as definitely the infinite HP series Vn is a divergent one. So from here we can say that the P series is convergent if P is greater than 1, and it is divergent when P is less than is equals to 1. So I hope you understand what is the comparison. Yes, there are some do by yourself questions. So I am giving 5 questions in this video. So the first question is this one, summation Un is equals to 1 plus 2 by 2 to the power 3 plus 1 by, plus 2 plus 3 by 3 to the power 3. Likewise, again the second series is given as summation Un is equals to summation of sine of 1 upon n. Third one is summation log n to the power of p. Fourth one is 1 upon n factorial only, summation of this one. And the fifth series is this one, summation Un is equals to 1 into 2 divided by 3 square into 4 square plus 3 into 4 divided by 5 square into 6 square. In this way it is following. So for all these above series, the test the convergency and write corresponding Vn for all those series. Understand? So you are supposed to find out that all these 5 series are divergent or convergent by using the comparison test, and not only that, you should write the corresponding Vn series Vn, which you should choose to compare those series in the comment box. So all these 5 questions for you write the answer, that is it is convergent or not, and what is the corresponding Vn in the comment section. So thank you all, and wait for the next video. There we will discuss more different tests to verify a series is divergent and convergent. So thank you all. Have a nice day.